In this tutorial, we'll take a look at the method of substitution. It's one of the two main algebraic ways to solve a system of equations. And substitution is most convenient, when you have a choice that is, to use when one of the equations is already solved for a variable, or it can easily be solved or rearranged for one of the variables, x, y, whatever the variables are. And in example 1 here, we're asked to solve this following system. So one equation is 4x plus y equals 7, and the second one is y equals 2x plus 1. Now the second equation, y equals 2x plus 1, is solved or rearranged for y already, so that's good. So that makes substitution a pretty efficient method for this system. The first equation could also be easily rearranged or solved for y because the y is a coefficient of 1, so we could do that if this wasn't already solved for y. Okay, so what we're going to do is, this is the way the substitution works, is once you've got an equation rearranged for one of the variables, so this in the second equation is what y equals. So what we're going to do is we're going to substitute that in place of y in the other equation. So what I'm going to do is I'm going to rewrite this first equation. So here's the 4x plus, that's that plus there, and instead of writing y, I'm going to write 2x plus 1 because we're putting that in place of y. There's what y equals in the first equation, and then equals 7. After you do the substitution, you now have an equation that only has one variable. So each of these has an x and a y term. So here you have just one variable, so we can solve for the variable that's left. We can solve for x. So 4x and 2x as the 6x, and subtracting 1 from both sides, 7 minus 1 is 6. And then we want to isolate or solve for x, so if I divide out the 6's, I get x to be 1. So now that I know that x is 1, I can find what y is. And actually in both the algebraic methods, the second part is the same. Once you find one variable, you substitute it back into either equation, it doesn't matter which one, to find what x is. So I can put the 1 here to solve for y, or I could put it here and solve for y. This one's a little more convenient because I'm trying to find y and it's solved for y. So that's why I'm going to use the y equals 2x plus 1, 1. And I'm going to put 1 in place of x here. So y would equal 2 times, see there's my 1 put in place of x. And 2 times 1 is 2, plus 1 is 3, so y is 3. So now I think that x is 1 and y is 3. Okay, I think that. So the way that I can check, I'm going to show you an algebraic check here. By checking, I don't mean look in the back of the book. So this is what you can do, if you're on a test or a quiz or something like that, or your final exam, to make sure that your solution is correct. These two, 1 for x, 3 for y, should make each of these equations true because there's supposed to be solutions to each of the equations. So what I'm going to do, and so this is my check here, so in this first equation the left side is 4x plus y, so I'm going to write LS stands for left side, 4x plus y, so I'm going to put 1 in place of x here and 3 in place of y. And if that evaluates to give me what's on the right side, in this case 7, then that 1 and 3 is a solution to that equation. It satisfies or fits the equation. So I'll put 1 here and my 3 in place of y. So 4 times 1 is 4 plus 3 is 7. So it equals what's on the right side. So I finish my check by saying that equals the right side. And as long as the left side and right side work out to be the same value, then that point, that 1, 3 is the solution to that equation. It also represents if we were to graph this line, an ordered pair that's on the line. So the point 1, 3 is a point on that line. So now we need to check for the second equation, the y equals 2x plus 1 equation. And the 2x plus 1 expression is the only thing we have to evaluate. See, there's just a y on the left, so there's nothing to evaluate on the left. So I'm going to start with the right side, the 2x plus 1, and I'm going to put my, now see, there's just an x here, so I'm going to put this 1 in place of x. So we will go 2 times 1 plus 1. That's 2 plus 1 is 3. See, it equals 3. See, 3 is what's on the left side. So the fact that that equals what's on the other side means that that point is on that line. So the solution is x equals 1 and y equals 3. Now, before we go into either of the other examples, if we were to graph these two lines, then they would also, the 1, 3 also means that they would intersect at the point 1, 3. So that's also the point of intersection if we were to graph those two lines. And one more thing about the check before we go to the other examples. Let's say that we had made an error. Back here, someone, finding the 1, 3. Let's say, for example, that for some reason we thought that we made an algebraic mistake. Let's say we thought that 0, 1 was the point where these intersect. So let's say we thought that x was 0 and y was 1. Okay, so this is just a for instance. Okay, so I want to show what happens in the check if you're checking the wrong point, the wrong solution. So you see in this line here, I would still start with my right side. Okay, so I would be putting 0 in place of x here. So I would go 2 times 0. 2 times 0 plus 1. And of course 2 times 0 is 0, plus 1 is 1. And so my y is 1. So this actually does check in that second equation because that is what's on the left side. Okay, so that point is on that line. But, okay, so let's check in this one here now. And so I'll do this up here. So my left side of that one is the 4x plus y. And remember, that's supposed to equal this 7 here. So I think for some reason that my x is 0 and my y is 1. So I'm going to put 0 here in place of the x in my equation. So 4 times 0 plus, I think that y is 1 for some reason. So 4 times 0 is 0 plus 1 is 1. But you see, it doesn't equal the 7. So that point isn't on that line. It's on the second one, but it's not the first one. So this doesn't equal what's on the right side. So the check didn't work because I got the wrong point. Okay, so it might be that you made some kind of mistake and it actually works in one equation, but it doesn't in the other. So it's not a solution. It has to satisfy both of the equations for it to be the actual solution to the system of equations. Because what you're trying to find is the point that they have in common. Okay, the point that's on both the lines. Okay, on to the second example. Now, in this one, so here's our two equations again, and you don't have one solved for x or y already. But this equation here is fairly convenient, fairly easy to rearrange for x, because x is a coefficient of 1. If x or y have a coefficient of 1 or negative 1, it's fairly easy to rearrange for those. So what I'm going to do is, this is what I'm actually doing here. Now you'll see some people will say I'm going to subtract 5. See, I want to isolate the x. So I'm going to subtract 5y from both sides. Some people will say, well, let's bring the y term over and it changes sign. It's a negative 5y on the other side. Whichever way you say that, those are the two most common ones. Then x would equal 18 minus 5y, or x is negative 5y plus 18. That's the same thing. So now that I have this second equation rearranged for x, I'm going to substitute that in place of x in the other equation. And so I'm going to rewrite this 3 times, so in place of my x, I'm going to put this 18 minus 5y plus the 2y equals 2. So now I have an equation that just has y's, so I can solve for y, I can isolate for y. So I'm going to distribute the 3 in here first. So 3 times 18 is 54, and 3 times negative 5y is negative 15y, plus the 2y equals 2. And let's collect like terms now that we've got this distributing done. So negative 15y and 2y is negative 13y. And I'm trying to isolate for y, so let's get rid of this 54. We'll take 54 away from both sides, so that's gone, and 2 minus 54 is negative 52. And then we can divide out the negative 13, so they're gone. And negative 52 divided by negative 13 is 4. So I think that y is 4. Now, I now need to find x. So this would be the most convenient equation to use to find what x is, because it's solved for x, so I can just substitute my 4 in place of y here. So let's rewrite this, and so we're going to put the 4 in here. So 5 times 4. So that's 20. So 18 minus 20 would be negative 2. So I think that x is negative 2, y is 4. So let's check again, like we did on the first example. So this equation here, this is the left side, the 3x plus 2y, and if I put my negative 2 and 4 in place of that, it should equal 2. If it doesn't, then we've made a mistake. So here's my 3x plus 2y. So I'm going to put my negative 2 here and my 4 here. So 3 times negative 2 is that's negative 6, and this would be plus 8, and negative 6 plus 8 does equal 2, so it equals the right side, so we're good for the first equation. So now let's take a look at the second one. And by the way, always check in the original two equations. See, this is a rearranged version of this. So if you've made an algebraic error from here to here, but everything else is correct, then you won't find that mistake if we now check in this one. Okay, so that's why I'm using both the original equations. So I'll use this is my left side for the second equation, the x plus 5y. And so I'm going to put my negative 2 here and my 4 here. So that's 20, and 20 minus 2 is 18, so it's supposed to equal 18. So that does check in the second equation. So the solution is negative 2, and x is negative 2, and y is 4. And just like I mentioned on the previous page, I didn't actually write it out like this, but again, this also means that if we were to graph these two lines, they would intersect at the point negative 2 comma 4. That would be the point of intersection of these two lines. Last example, number 3 here. This is a bit of a word problem, and I'm going to show how you get to a system of equations from the word problem, and then we'll solve it. So Tom and Mary have a total of $19 in loonies between them, and remember, a loonie is worth $1. Mary has one more than twice the number of loonies as Tom. How many loonies do they each have? Now you might be able to figure this out just by trial and error or inspection. Okay, they got 19, so maybe it's 2 and 17 or 5 and 14 or something like that. But I want to show how to do this by using a system of equations and using the substitution method. So to make those equations, you should create a let statement which describes your variables. So I'm going to let T and M represent the number of loonies Tom and Mary have. And again, the word respectively means that my first variable belongs to the first person. So T is Tom and M would be Mary. The first sentence says Tom and Mary have a total of $19 in loonies between them. So that sentence would translate to the equation T plus M equals 19. Tom's loonies plus Mary's loonies add to 19. They have 19 between them. That's what that equation says. The second sentence says Mary has one more than twice the number of loonies as Tom. So Mary's is double Tom's plus 1. One more than twice as many. So there's the twice as many plus 1. So Mary's is equal to double Tom's plus 1. So that's my second equation. And this equation is solved for M, solved for Mary. Okay, so the way the solution, the substitution that would be most convenient is we would take this and substitute it in place of M in that equation. So let's rewrite the first equation, t plus, and so in place of the m, we're putting the 2t plus 1 equals the 19. Collecting like terms, 2t and t add to 3t, and I'm trying to isolate for t, so if I take 1 away from both sides, 1 subtract from 19 is 18. And then if we divide out the 3, so like this, then we'll get t equals 6. So that would mean that infers that Tom has 6 loonies. So now I want to find out how many Mary has. So I'm going to use the first equation. You could use the second equation. It wouldn't matter. Either will work. So I'm going to put my 6 right in here. So, sorry, no, in place of Tom. So 6 is here. 6 plus m equals 19. So what do you add to 6 to get 19? Well, it'll have to be 13, or you could just do the linear equation things and subtract 6 from 19, so that's also 13. So it looks like Mary is 13. So let's check. So I'm going to check more in the sentences than the actual equations here. I want to make sure it checks with what these two sentences say. So Tom and Mary have a total of $19 in loonies between them. So if we add 6 and 13, okay, Tom has 6, Mary is 13. That does add to 19, so it makes sense with the first sentence. Mary has 1 more than twice the number of loonies as Tom. Well, we think that Mary is 13. 13 is twice 6 plus 1. Okay, double Tom's, which is 12, plus 1 is 13. So that does make sense within the second sentence. So therefore, Tom has 6 loonies, and Mary has 13 of them. And that's the end of the tutorial.